Hello students, welcome back to your favorite YouTube channel, Tomachang Tutorial. Myself Kishan Gulum, and today we are here to discuss about a new topic, that is expansion of gas. We have already completed the expansion of solid, expansion of liquid in our previous videos. Please find the link below in the description and do watch that video, okay? Now let us move to the topic, expansion of gas. First of all, let me tell you, gases also do not have its shape and size, so we consider only the expansion of volume of gas, not the superficial expansion or the linear expansion. Gases, when expands, only the volume of gas expands, no area, no length, okay? Now let me give you an example for the expansion of gas. Suppose we have an empty bottle and this bottle is fitted with a cork. This is an empty bottle fitted with a cork. If you heat this bottle for a long time, what happens is this cork is seen blown away with a pop sound. When you heat the bottle for a long time, this cork is blown away with a pop sound. What does this mean? This means the bottle was empty, but the bottle actually is not empty. There is gas inside the bottle, isn't it? When you heat the gas expands in volume, and when the gas expands in volume, the pressure of the gas actually pushes out this cork. So we understood from this example, gases expands in volume on heating, okay? Now let's move on to the topic, the coefficient of expansion of gas. Okay, the coefficient of volume expansion of a gas at constant pressure is defined as the fraction of its volume at 0 degrees Celsius by which the volume of a fixed mass of gas expands per degree Celsius rise in temperature. Okay, let me explain. Let us suppose a fixed mass of gas at constant temperature and 0 degrees Celsius, okay? Now, when you increase the temperature, the volume of the gas also increases. And now the increased volume of the gas divided by original volume per degree rise in temperature is called the coefficient of volume expansion of gas. Let me deduce that and I'll make you understand that. Please take the screenshot of this definition. Okay, I'm going to erase this. Let the volume of fixed mass of gas at constant pressure and 0 degrees Celsius temperature be V naught, okay? When the temperature was 0 degrees Celsius, the volume of the gas is V naught. Keep in mind, pressure is kept constant and mass of the gas is kept constant, okay? Now, and at V2 at, V theta at higher temperature theta degrees Celsius. When the temperature increases from 0 degrees Celsius to theta degrees Celsius, the volume of the gas also increased from V naught to V theta. Got my point? When the temperature was 0 degrees Celsius, the volume was V naught. When you increase the temperature from 0 degrees Celsius to theta degrees Celsius, okay, the volume of the gas also increased, because when you increase the temperature, volume also increases and volume increases to V theta. Got my point? Okay. For theta degrees Celsius rise in temperature, because increase in temperature is theta degrees Celsius, new temperature minus old temperature. Old temperature, original temperature is 0 degrees Celsius, so theta degrees Celsius minus 0 degrees Celsius becomes theta degrees Celsius, isn't it? So increase in temperature is theta degrees Celsius. Theta degrees Celsius rise in temperature, increase volume of gas equal to V theta minus V naught, isn't it? New volume is V theta at temperature theta degree Celsius, and original volume was V naught at 0 degree Celsius. So the increase in volume is new volume minus original volume. Okay, how much the volume increased? V theta minus V naught. So for theta degree Celsius rise in temperature, increase in volume of the gas is V theta minus V naught. Unitary method now. For 1 degree Celsius rise in temperature, increase in volume of gas equal to V theta minus V naught upon this theta comes down, isn't it? Unitary method. So definition of the coefficient of volume expansion of gas: fractional increase in volume of gas per degree Celsius rise in temperature equal to increased volume by original volume is fractional increase, isn't it? So increased volume is V theta minus V naught. So fractional means divided by original volume into increase in temperature is theta degree Celsius. You can write theta degree Celsius here. Okay. So this is actually called the coefficient of volume expansion of gas, isn't it? Coefficient of volume expansion of gas is denoted by letter gamma P, okay, equals to V theta minus V naught divided by V naught into theta degree Celsius. This is the coefficient of volume expansion of gas. Okay, please take the screenshot. I am going to find the increased volume of V theta when the temperature rises to theta degree Celsius. Okay, please take the screenshot. I am going to erase this. Since we have gamma P equal to, gamma P means coefficient of volume expansion of gas, isn't it? Gamma P equal to V theta, that is increased in volume, increased or new volume of the gas when the temperature was theta degree Celsius. New volume of the gas when the temperature is theta degree Celsius. V theta minus V naught divided by V naught into theta degree Celsius. Okay. Now let us cross multiply this. Gamma P into V naught into theta degree Celsius equal to V theta minus V naught, isn't it? Or let us bring this V naught to the left hand side. Gamma P into V naught into theta degree Celsius plus V naught equal to V theta. Now let us take the common out, that is V naught, or V naught common remains within the bracket. Gamma P, V naught is out, into theta degree Celsius plus this V naught is out, so we write 1 equal to V theta. Okay, let us say this is equation 1. Okay, V theta means new volume of the gas at temperature theta degree Celsius is this much. So from Charles' law we know that, let me write the equation of Charles' law. Okay, Vt equals to V naught 1 plus T upon 273, isn't it? This is the general equation of Charles' law. Vt is the volume of the gas at temperature T degree Celsius, and V0 is the volume of the gas at 0 degree Celsius. Okay, Vt means the volume of gas at temperature T degree Celsius. At this temperature, volume of gas is Vt, and this V0 is the volume of gas at 0 degree Celsius. Please find the link below in the description and watch Charles' law. Okay, we have already completed Charles' law and we have deduced this relation. This is the equation of Charles' law. Vt is the volume of the gas at T degree Celsius, and V0 is the volume of gas at 0 degree Celsius. Okay, now from Charles' law, from Charles' law, at volume of gas, okay, volume of gas at theta degree Celsius, is V theta. If the volume of gas at T degree Celsius is Vt, then volume of gas at theta degree Celsius is V theta, isn't it? V theta equal to volume of gas at 0 degree Celsius, similar, 1 plus temperature, here was T and here we have temperature theta, so theta upon 273. Got my point? This is equation 2. This is the equation of Charles' law. This is the volume of gas at theta degree Celsius, at temperature theta degree Celsius. Volume of the gas is V theta, and this V0 is the volume of gas at 0 degree Celsius. Okay. Okay. Now let us equate equation 1 and equation 2. From 1 and 2. In equation 1 we have V theta equals to this much. In equation 2 we have V theta equals to this much. This V theta equals to this, and this V theta equals to this. That means this both V theta is the volume of the gas at theta degree Celsius. So these two should also be equal. So please take the screenshot of this. I am going to erase the upper part to clear so that I get enough space to write and continue. Okay. Since V theta equals to this in equation 1 and V theta equals to this in equation 2, so in both the cases these and these are equal. So we can write V0 gamma P theta degree Celsius plus 1, isn't it? V0 gamma P theta degree Celsius plus 1 equals to V0 1 plus theta upon 273, 1 plus theta upon 273. Got my point? If V theta equals to this, here V theta equals to this, then these two should be equal. Got my point? Okay. I hope you got this. Now, this V0 and this V0 can be cancelled, because if I take this V0 here, it goes to the denominator by cross multiplication. So denominator V0 and the numerator V0 can be cancelled. So let us cancel this V0 here itself. Now remains gamma P theta degree Celsius plus 1 equal to 1 plus theta upon 273. V0 cancelled. So this plus 1, if we take to the right hand side, becomes minus 1, and that minus 1 and this plus 1 becomes 0. So you can cancel this 1 here. Okay. Are you getting my point? Now comes gamma P theta degree Celsius equal to theta degree. This theta is also degree Celsius. Okay, theta degree Celsius upon 273, isn't it? This is also temperature in degree Celsius. This is also temperature in degree Celsius. So if you take this theta degree Celsius to the right hand side, by cross multiplication it goes to the denominator, so this can be cancelled. So let us cancel here itself. Therefore we got gamma P equals to 1 upon 273. This means the coefficient of volume expansion of gas is 1 upon 273. Okay, the coefficient of volume expansion of gas, the value of the coefficient of volume expansion of gas is 1 upon 273. This is a constant number. Okay, please keep this in mind. Thank you so much for watching this video. I hope you liked this video and understood the concept which I tried to teach you, and Stay safe, stay healthy, stay happy, okay? Because happiness is directly proportional to the positive energy. More you become happy, more positive energy you get, and more positive energy you have, the more energetic you become and more intelligent you become. So be positive, be happy, and please don't forget to subscribe and hit the bell icon for notifications for more video uploads. Thank you.